Hello, everybody. Let's get rolling on a new idea. And in this section, we're going to start to talk a little bit about solving, right, radical equations. All right, we're going to start to solve equations with some radicals in there. All right, so we are solving some radicals. And so if we take a look at a problem, let's say we have something like 2 times the square root of x plus 1 equals, yeah, we'll say equals 4. Okay. Um, And one of the things we talked about in 5.1 and a little bit in 5.2 is that we want to work from the outside and we want to work in because our goal is to get x by itself. So we're going to work from this outside and we're going to work in. We're going to start to undo things so we can solve for x. So the first thing we're going to do here, well, on the very outermost thing, we have a 2 here on the outside. So we can divide both sides by 2. And that leaves us the square root of x plus 1, right, equals 2. And we've even talked about, let me extend my square root. We've talked about how to undo a square root, you would need to square both sides. If this were, let's say, a cube root, you would just cube both sides. So, and again, if there's no number, if there's no index there, we assume it's a 2. So we're going to square both sides. So squaring undoes the square root. So we're left with x plus 1. And then over here, 2 squared is 4. So this works out very nicely, and that x equals 3. Now, if we go and check our answer, we could say, all right, 2 times the square root of 3 plus 1. Notice I'm just substituting in 3 wherever I see x. Um, does that equal 4? That's our question. Sorry, I'm getting off my screen a little bit. Well, 3 plus 1 is 4, so we have 2 times the square root of 4. Does that equal 4? Well, square root of 4 is 2. And yes, 2 times 2 does equal 4. So in this scenario, our answer works and we're good to go. Let's try one more. We'll go a little bit of a new page here. This time, and let's change our color a little bit. We're going to say, we're going to take the cube root of 2x minus 5. Okay, and we're going to subtract 2, and we'll set that equal to 3. Okay, again, work from the outside in. I encourage you to take a minute, pause your video, and see how far you can get. And then if you get stuck, go ahead and follow along with me. So go ahead and take a minute and do that right now. All right, first thing we're going to do, again, we're working from the outside and we're working in because our goal is to get x by itself. So we're going to add 2 to both sides. Notice the minus 2 is not underneath this radical. So it's the farthest thing away from the x. So yes, we're going to add the 2 to both sides and we'll get 5. And over here we'll have the cube root of 2x minus 5. All right. And now to undo a cube root, we are going to cube both sides. So cubing undoes the cube root, so we're left with 2x minus 5. And 5 cubed, 5 times 5 being 25. And if you have 25 times 5, well, that's 5 quarters. So you have $1.25 or 125 cents. And from there, it's pretty straightforward in terms of getting x by itself. So we end up with 2x equals 130, or x equals 65. All right. Now that we have our solution, we have our answer, we could go back in, we could plug it in for x. I will leave that to you, but you should find that, yes, this does work out and both sides are equal to each other. Okay. We're halfway there. So we got 2 of the 4 problems. So a couple other ideas that we might see. What happens if we have x's on both sides of the equation? So for example, maybe we see something like x plus 1 equals the square root of 7x plus 15. Say, Mr. Jones, now how do I get x by itself? Because that's what you told me. We work from the outside in, get x by itself. Well, to start, we don't really like this radical sign here, do we? So let's square both sides. All right, we're going to square both sides. And so that's going to undo each other there. But what you do to one side of the equation, you have to do to this other side of the equation. So we're going to square this entire side. Okay, we're going to take the entire quantity over here, this entire quantity x plus 1, and we're going to square it. Okay, so on the left, we said, all right, we're on the right, I'm sorry, we have 7x plus 15. And please don't be one of those people. I think some of you know that this is my biggest pet peeve, the people that tell me that, oh, this is x squared plus 1. Okay, I'll give you a hint. It's not. Okay, what we have to do is we're going to take x plus 1, and squaring it means multiply it by itself. So we're going to take x plus 1 times x plus 1, and when we FOIL this out, okay, you'll get x squared. You do your inside and your outside terms, you get plus 2x plus 1. So now really we have x squared plus 2x plus 1 equals 7x plus 15. Okay. From here, this is why we spent so much time at the very beginning of the trimester solving quadratics, because it's a really important skill for you guys. And actually it comes back into play here. So let's move all our like terms so they're all on the same side. So I'm just going to subtract 7x from both sides and subtract 15 from both sides. So we'll get a 0 over here. And we're left with x squared minus 5x. All right, sorry, this was a minus 15. And so this becomes a minus 14. And now we have a quadratic, and it's set equal to 0. So we can use one of our 3 strategies for solving quadratics. In this case, I'm going to pick factoring because this turns out factors pretty nicely. Some factors of negative 14 that add up to negative 5 are negative 7 and 2. So I could say x minus 7, right, and x plus 2. Okay. Let me get rid of let me scroll up a little bit. And that equals 0. That is equal to 0. So our solutions are going to be x equals 7 and x equals negative 2. Now, if I go back to the very beginning, my very equation at the very beginning, we want to know, hey, does x plus 1 equal the square root of 7x plus 15? So I could plug both of these in. I say, all right, x plus 1, well, 7 plus 1 would be 8. Does that equal, I'll put a little question mark over it because we don't know yet, does that equal the square root of 7 times 7 plus 15? Plus 15. Well, 7 plus 7, or 7 times 7 is 49. 49 plus 15 is 64. So does 8 equal the square root of 64? And it turns out it does. So 7 works. Give a little check mark. And we could do this exact same thing if we tried it with negative 2. So we could say, all right, actually, let me get my eraser tool out. Give us a little space here. Okay. Does negative 2, does that equal, or sorry, negative 2 plus 1, so this should really be negative 1. Does negative 1 equal the square root of 7 times negative 2 plus 15? So does negative 1 equal, well, 7 times negative 2 is negative 14. Negative 14 plus 15 is 1. So does negative 1 equal the square root of 1? And the answer is no. So this one does not work. This is what we would call an extraneous solution. All right. Let me spell that out. EX. All right. Extraneous. Okay. So in some cases, you may get 2 solutions, but you need to check and make sure that both of them work. In this case, 7 would be a real solution and negative 2 would be an extraneous solution.